Good evening, ladies and gentlemen. On behalf of the Connecticut Department of Transportation and the towns of Westport and Fairfield, I would like to welcome you all for attending this public informational meeting for State Project number 158-218, replacement of bridge number 4971, located on Old Road number 2 over Sasco Brook in the towns of Westport and Fairfield. My name is Preeti Bardwaj, and I am the project manager assigned to this project. We appreciate your willingness to participate in this forum virtually, and we hope that you will find this meeting both interesting and informative. I would now like to go over some of the goals and format for tonight's meeting. I will explain how you will be able to interact with the project team. I will be explaining how this project is funded in the Federal Local Bridge DMS or Design Managed by the State program. We will be having some welcoming remarks from the towns of Westport and Fairfield. I will then be introducing the project design team, and that includes the department's front office leadership, the department's design team, and our consultant liaison engineer team. This will be followed with a technical portion of the design, which will include the condition of the existing structure, purpose and need for the project, and the recommended design solution, which has progressed to a 30% design completion. As part of the department's public outreach program, it is at this point now that we are reaching out to you, the public, while it is still early in the design process, to receive any comments or concerns and answer any questions that you may also have. We will also be explaining how the rights-of-way process works for this project. And lastly, we will have the live question and answer session. I will now explain how you will be able to interact with the project team. There are three means of how you will be able to communicate. The first is by email, which is dot-flbp@ct.gov. I will also spell that out. It is dot-flbp@ct.gov. You can also phone in. The telephone number is 860-944-1111. Again, the phone number is 860-944-1111. Or you can also communicate by chat on the MS Teams live event chat. In this format, you can ask a question by clicking on the little question mark, which shows Q&A. This will bring up your live event Q&A field. Select the Ask a Question button at the bottom right screen, and a field will pop up. And you can type your question and hit either enter with a little arrow button to send. You can also check the box on the bottom to post your question anonymously if you prefer. There will be a slight delay, but eventually your question will appear in the featured section with all other questions that are asked tonight. The project email, phone, and chat will be screened by the project team during the Q&A session, and the questions asked by any of these methods will be posted to the MS Teams Q&A chat window. The questions will then be asked out loud for the project team to answer. You can ask questions at any time during the presentation, but we will answer these questions only during the live Q&A session that follows. We also have the project webpage link, where the recording of tonight's entire presentation, including the Q&A session, will be stored. The webpage will also contain the same information that I have previously explained on how to provide comments and ask questions. And that project webpage is portal.ct.gov/DOT Westport 158-218. And again, I will spell that out. It is portal.ct.gov/DOT WESTPORT 158-218. And lastly, please remember the comment period to ask questions or provide comments will be open through October 4th, 2021. So if you think of a question after tonight's meeting or want to expand on a question asked tonight, you will have until October 4th to do so. The MS Teams chat function is only available during tonight's live Q&A session. We would greatly appreciate it if you could fill out a brief survey that the department has through SurveyMonkey. The virtual public informational meeting platform is still a relatively new one for the department, and this survey will help the department improve these public meetings going forward. There's also a civil rights flyer available. Both the links to the survey and civil rights flyer are located on the previously mentioned project webpage. And lastly, I am required to read the following statement as part of the Title VI Civil Rights Act, and that is, no person shall, on the basis of race, color, or national origin, be excluded from participation or subject to discrimination in the development of this project. I would now like to explain how this project is being funded. This bridge is a town-owned bridge and is being funded under the department's federal local bridge program. Traditionally in this program, the town selects a designer, and because federal funds are involved, the department provides administrative oversight because the department is considered to be stewards of those federal funds. The funding is traditionally 80% federal and 20% town for the design, rights-of-way, and construction phases of the project. However, this project is going to be funded under the department's DMS, or Design Managed by the State program. In this program, it will be the department who will be performing the design on behalf of the municipality, utilizing our consultant liaison engineers. In this case, our consultant liaison engineers are Clough Harbor Associates, or CHA. CHA has completed the 30% preliminary design, and it will be brought to final design completion by one of our pre-selected task-based designers. In addition, the design phase only will now be funded with 80% federal and 20% state funds, so the entire design phase is at zero cost to the town of Westport and Fairfield. Although the preliminary design was performed by the department, it was in full partnership and coordination with both the town of Westport and Fairfield. We held several meetings with both of the towns and diligently worked together to incorporate most of the town's comments and concerns. And now we are reaching out to you, the community, to also weigh in. The initiative behind the DMS program was to expedite design delivery for municipal projects. The department is pleased to be able to offer this program to the town of Westport and Fairfield. The DMS program is spending your municipal and state tax dollars both efficiently and effectively, and at the same time fostering great working relationships with our municipal partners. And with that, I'll now hand it over to Mr. Keith Wilberg and Mr. Bill Hurley from the towns of Westport and Fairfield, who have some opening remarks.
Thank you, Preeti. My name is Keith Wilberg, and I am the town engineer at the Westport Department of Public Works. We are looking forward to a successful bridge replacement project with the town of Fairfield. I'd like to introduce William Hurley from the town of Fairfield. Thanks.
Good evening, everyone. This is Bill Hurley from the Town of Fairfield Engineering Department. I wish to welcome everyone to tonight's presentation. We look forward to helping facilitate this project with the state of Connecticut and the town of Westport. We worked closely with state DOT and trust that they'll lead us in the direction of a successful project for this bridge replacement. Thanks, and back to you, Preeti.
I would now like to introduce the project team. I'm Preeti Bardwaj, project manager. We also have present the department's front office leadership, and that includes Mr. Bart Sweeney, Division Chief of Bridges, and Mr. Louis Bacho, Principal Engineer. We also have Mr. James Barrows, Project Engineer, and we also have our consultant liaison engineers, who are Clough Harbor Associates, assigned to this project. And from Clough Harbor Associates, we have Mr. Anand Shazadri, Project Manager, and Mr. Rob Baylor, Project Engineer. So, ladies and gentlemen, we are finally ready to present our technical portion of the presentation, and you will be hearing a lot of bridge lingo throughout the presentation. Therefore, I am about to give you a 2-minute crash course on some of the structural elements on a bridge and the numerical condition rating system assigned on a bridge. On the diagram shown, the deck is the riding surface of a bridge. The parapets, or sometimes bridges can also have an open rail system, helps prevent errant vehicles from going off the bridge. The beams, or the girders, are the supporting structural elements on the bridge and are designed to support vehicular loads and the self-weight of the bridge and any environmental loads such as wind, seismic, etc. The parapets, deck, and the beams or girders make up what is known as the superstructure of a bridge. The abutments and wing walls are the end supports on a bridge, and the piers, if there are any, are the intermediate supports. The abutments and wing walls and piers make up what is known as the substructure of a bridge. The substructure not only supports the superstructure, but also helps in transmitting loads from the superstructure down to the bridge foundations. All state bridges and town bridges over 20 feet in length are inspected every 2 years by the department's Bridge Safety and Evaluation Unit and are assigned a condition rating on a major structural element on a scale of 1 through 9, with 9 being excellent condition and 1 being imminent failure condition. When a major bridge element reaches a 4, or poor condition, that is when we start to initiate a project to address the structural deficiencies. Now that you are armed with basic bridge knowledge, I would now like to introduce Mr. Rob Baylor from CHA, who will be presenting the technical portion of the presentation.
Thanks for the introduction, Preeti. Good evening, everyone, and thanks for joining tonight's presentation regarding the recommendations for rehabilitation of bridge number 04971, Old Road number 2, or Wakeman Lane, over Sasco Brook. Shown here is a site overview of the project location. Bridge number 04971 is shown here in the center, and the bridge carries Old Road number 2 and Wakeman Lane running east to west through the project location. Sasco Brook runs north to south through the area underneath the bridge, and the center line of the brook also serves as the approximate town line between Fairfield on the east and Westport on the west. Gristmill Lane comes in from the south and intersects with Old Road number 2 just adjacent to the bridge on the west side. Also on the northwest side of the bridge, directly adjacent to the project, is the Sasco River Carrick open space. Old Road number 2 and Wakeman Lane carry approximately 309 vehicles per day, according to a traffic count taken in March of 2021. However, we assume that this value is slightly skewed due to the decreased traffic during the pandemic, and we assume then that the actual average daily traffic is somewhere between 400 and 1,000 vehicles per day. Here's the existing bridge plan, which shows the brook running north to south and the roadway east to west, and Gristmill Lane directly adjacent to the bridge on the west side. You can see in the plan the poor alignment of the bridge, which is at an angle to the approach roadway. The bridge span is approximately 24 feet in length. On the west side of the bridge are stone masonry barrier walls on both the north and south sides. And on the east side is a timber guide rail bridge attachment. On the north side of the bridge are utility poles, shown here and here. And on the south side is an existing water line which runs through the Sasco Brook channel and back into the roadway on the east side of the bridge. The bridge was originally constructed in 1965 and was rehabilitated in 2002. Shown here is the existing cross-section of the bridge. So say we take a perpendicular slice through the center of the bridge and look along the roadway, this is what we would see. The center line of the bridge is here, and the roadway width across the bridge is 16 feet 8 inches. The superstructure consists of an open steel grid deck, which is supported on 9 longitudinal steel stringers. These run parallel with the road. The stringers are supported on 3 transverse steel floor beams, which run perpendicular to the road, and then these are supported on 2 steel through girders, shown here. These through girders also act as the traffic barrier along the bridge. The existing bridge is considered fracture critical. By fracture critical, I mean that if just one of these girders fails, the entire bridge will fail. The traffic rail is of special concern because if a vehicle impacts this rail, it also compromises the structural integrity of the entire bridge. Bridges of fracture critical nature are not desirable by either town. This here is a sketch of the south elevation of the existing bridge. The bridge is approximately 24 feet in length. The aforementioned superstructure rests on top of concrete abutments and wing walls. These are then founded on spread footings. At the approaches are stone masonry barrier walls on the west side, and on the east side, a timber guide rail. Hydraulically, the existing bridge does not pass the 25-year storm event, as shown by the water surface elevation here. As previously described to us, the condition of the bridge elements are rated on a scale of 1 to 9, with 1 being the worst and 9 being the best. A summary of the major bridge elements are shown here, which are based on a bridge inspection performed in February of 2020. The deck is rated in good condition at a 7. The superstructure is rated at a 4 in poor condition, which classifies the bridge as structurally deficient. This is what warrants the existing load restriction of 10 tons on the bridge. The substructure, approach roadway, and stream channel are all rated at a 6 in satisfactory condition. The deck geometry is in intolerable condition with a rating of 2, which requires a high priority of replacement and classifies the bridge as functionally obsolete. The scour critical rating is rated a 3 and classifies the bridge as scour critical. The ratings shown here of 4 and lower are what warrant the bridge rehabilitation project. To give you a better visual of the existing site, here are a few photos of the bridge and roadway. Starting on the top left is a photo of the downstream elevation of the bridge. To the right of that is a photo of the upstream elevation. Notice the overgrowth of vegetation in the upstream photo, which was taken during the summer. Moving to the lower left photo is the west approach from the Westport side, looking east over the bridge. Note the utility pole on the left side of the roadway. Also shown in this photo on the right side is Grist Mill Lane coming in from the south. The last picture on the right of that is a photo looking to the west over the bridge from the east approach. Notice in these two lower photos the narrow roadway width of 16 feet 8 inches, which is what classified this bridge as functionally obsolete. Here are a few photos of the existing bridge elements. Photo on the top left shows the open steel grid deck and the southern through girder, which supports the superstructure of the bridge. Along the bridge is the rub rail, which acts as the curb, and on the left side is a timber guide rail attachment, although it's hard to see here. On the right side is the masonry barrier wall. The photo to the right of that shows the northern through girder and the rub rails along the bridge, and also a steel plate along the north side, which acts as a sidewalk. The photo to the lower left is the underside of the superstructure, which consists again of the open steel grid deck, the longitudinal stringers, and the transverse floor beams, which are all then supported by the two girders. Below that is the east abutment and the Sasco River below. The photo to the right is a typical deterioration at some of the superstructure elements. Shown here is the connection at the floor beam and girder, which notice you can see peeling paint and rust deteriorations. These deteriorations are what govern the superstructure rating as poor. Due to the deterioration previously shown, the structural deficient bridge is posted with a 10-ton weight limit, as shown in this first photo. To the right of that is an underwater photo at one of the bridge abutments. This is showing the undermining of the bridge where water has eroded underneath the concrete foundation. This is what identifies the scour critical bridge classification. The two lower photos show the downstream and upstream channels of the bridge, which are well protected with boulders and vegetation along the embankment. The project purpose and need will summarize the main points of concern with bridge number 04971. First, it has been 55 years since the original construction of this bridge. Next, the roadway width of 16 feet 8 inches is inadequate for both state and federal standards. The table shown here below shows the minimum roadway width requirements of the Federal Highway Administration and Connecticut DOT. For an average daily traffic between 400 and 1,000 vehicles per day, the roadway width requirement is 24 feet to meet both state and federal standards. Also, the town of Westport and Fairfield have minimum width requirements of 26 and 24 feet respectively. The existing bridge and approach traffic rail system do not meet current safety standards. The two girder bridge is considered fracture critical, and the bridge is also structurally deficient because of the poor conditions of the floor beams and girders, creating an inadequate load carrying capacity of a 10-ton posting. Hydraulically, the existing bridge does not pass the 25-year storm event, and the undermining of substructure classifies this bridge as scour critical. Lastly, there is poor horizontal and vertical roadway alignment. Therefore, the purpose of this project is to address all the needs presented here and provide a new, safe, and competent bridge and roadway system that will serve the community for many years. Please note that despite the deficiencies presented here, the bridge is still safe for the traveling public. Because of all the concerns presented at this bridge, and in order to fulfill the purpose, we recommend a full bridge replacement with a precast concrete 3-sided rigid frame. This would provide a 75-year service life. An example of this bridge type is shown in the photo on the left. Roadway modifications would result in a 24-foot wide roadway at the approach and over the bridge. The bridge would also utilize a crash-tested bridge rail system, and this can be shown in both photos here below. A timber guide rail is proposed at the bridge approaches, and this structure type would allow for hydraulic improvements in the passage of the 100-year storm event. As part of this project, we also recommend a minor realignment of a portion of Old Road Number 2, or Wakeman Lane, to improve drivability through the Gristmill Lane intersection and over the bridge. I'd also like to mention here that we also considered other types of bridges, such as replacing the bridge with another two-girder bridge or a truss bridge. These bridge types were disregarded because they are fracture critical and would require much more maintenance than this three-sided frame, which we recommend. As I mentioned, the bridge is proposed to be a precast concrete three-sided rigid frame, as shown in this plan and elevation view in orange. On the elevation view below, we can see that the proposed improvements are to increase the bridge span to 38 feet in length. In order to meet the 1.2 bank full width requirement for permitting, the low chord elevation of the bridge will be raised just over 1 foot from the existing bridge. The combination of this and the longer span is what allows passage of the 100-year storm event under the structure. To avoid as many impacts to the surrounding properties as possible, it was determined that raising the profile 6 inches would allow the project needs to be met with minimal impacts. In the plan view, Sasco Brook runs north to south as shown in blue underneath the bridge. Old Road Number 2 and Wakeman Lane travel east to west as shown in yellow, and the proposed structure will require wing walls at all 4 corners as shown in gray in both the plan and the elevation views. Curved wing walls will be used at the northeast and southwest corners of the bridge due to the nearby driveway up here in the top right and Gristmill Lane in the top left of the plan. At the northwest and the southeast corners will be U-type wing walls built parallel with the roadway with a timber beam guide rail attachment shown here in pink in both the plan and the elevation view here. In the plan shown, the fill limits are shown in green and in brown. The three-sided frame will be built on pile foundations as shown here in the elevation view. Also, the crash-tested bridge rail will be installed along the length of the bridge as shown here. The exposed concrete surfaces of the wing walls will be faced with form liner concrete. This view shows a section of the bridge. We can see that the structure will provide a roadway width of 24 feet. Shown here is the 3-beam metal traffic rail along the sides of the bridge. The bridge will have a bituminous concrete overlay or asphalt with a waterproofing membrane to help protect the structure. The 3-sided frame members shown here will set on top of a pile foundation. To make this bridge visually presentable, we closely coordinated with representatives from both the towns of Westport and Fairfield. We recommend to install a concrete form liner on the exposed concrete surfaces. The concrete color and pattern will be chosen by the town to replicate the choice of stone. The 2 photos on the right here show a representation of what the stone form liner could look like. Also proposed is an open bridge rail, which can be metallized to the town's color choice. The photo on the lower right is a good representation of a proposed bridge rail. Lastly, a timber guide rail system will be installed at the 2 corners of the bridge, similar to what is shown in the photo on the left, which is the Valley Road Bridge in Fairfield, where many of these elements were recently constructed. Here's a roadway profile of Old Road Number 2, a horizontal view of the longitudinal limits of the project. West is on the left and east is to the right. Please note the vertical axis of this plan is exaggerated on a scale of 10. As discussed, The proposed bridge will raise the roadway profile approximately 6 inches from the existing condition. This can be seen in green on the plan here. Because the existing bridge does not pass the 25-year storm event, the raise in profile, the shallow depth of the proposed superstructure, and the increased span of the bridge will improve hydraulic flow under the bridge. In the proposed condition, water will pass under the structure and also eliminate overtopping of the roadway at the low point to the west of the bridge during the 100-year storm event. In order to tie this profile into the existing roadway on both sides of the bridge, the roadway will need to be constructed approximately 125 feet on either side of the structure. This is a profile of the Gristmill Lane roadway. The left is to the south and right is to the north, where the road ties into Old Road number 2, right here. In order to match the profile raise of Old Road number 2, Gristmill Lane will also need to be raised approximately 6 inches, as shown here in green on this profile. This will tie into the existing roadway on the south of the intersection. The roadway plan view shown here shows the complete extent of roadway reconstruction and the realignment of the roadway as part of this project. Sasco Brook again flows north to south, and Old Road number 2 runs east to west. The proposed roadway alignment shown will be a tangent or straight roadway segment from the east extending across the bridge and will tie into the west side with a single horizontal curve. This roadway configuration will help channelize traffic through the intersection of Gristmill Lane and over the bridge, meeting turning movement standards for trucks at the Gristmill Lane intersection and provide a consistent lane width across the bridge of 12 feet. Roadway construction limits extend 125 feet on either side of the bridge and approximately 100 feet to the south on Gristmill Lane. To compensate for the profile change, some drainage work will need to be done on both Old Road number 2, Wakeman Lane, and Gristmill Lane due to the raise in profile. Also, along Wakeman Lane will be a driveway that needs to get regraded, and on Old Road number 2. This improved alignment will help provide safe passage for vehicular traffic through the intersection and across the bridge. On this slide, I'd like to explain how we would like to handle traffic during construction. In order to construct the project safely and efficiently, a road closure and detour is proposed throughout the duration of construction. The purpose of this method of traffic control is to provide a safe work zone for residents, commuters, and the contractor. It also allows for a short construction duration because a contractor has room to work and can perform the majority of bridge construction operations without traffic being in the way. The proposed detour selected by the towns is as shown on the map to the right. Starting at the bridge, circled here in red, and going clockwise, the detour travels east on Wakeman Lane to Holes Highway. It then goes south on Holes Highway to Route 1, where it travels west to North Bulkley Avenue. Traveling north from there, the detour brings drivers back to Old Road number 2 for a total length of 1.9 miles. Along with this project, there are a few utility and environmental impacts we need to consider. Starting with utilities, the overhead utilities on the north side of Old Road number 2 and Wakeman Lane will need to be temporarily relocated. The photo on the right shows utility poles, both here in Fairfield and beyond the bridge in Westport. On the south side of the bridge, running through the stream bed, is a water main that will need to be permanently relocated as part of this project. This can be seen in the photo on the lower right. Also, on Old Road number 2, Wakeman Lane and Gristmill Lane, there are drainage catch basins that will need to be modified due to the raise and roadway profile. The environmental impacts include tree clearing along the roadway and wetland and watercourse impacts along Sasco Brook. The permits anticipated for this project are local inland wetland permits from both the town of Westport and the town of Fairfield. The state permit will be a flood management certification, MOU, and lastly, depending on the project's impacts, the federal permit requirement will be an Army Corps of Engineers self-verification or pre-construction notification permit. Due to the roadway improvements as part of this project, we will also have some small rights-of-way impacts to nearby properties. The limits of these impacts can be seen in the map to the right. I will explain the impacts at each property, starting with the property at the top, middle, and going clockwise around the bridge. Starting here, the Sasco River Carrick open space, owned by the town of Fairfield, will have a temporary construction easement. To the right of that, property 288 Wakeman Lane will also have a temporary construction easement and a right to grade and reconstruct the driveway apron shown here. Below that, on the south side of Wakeman Lane, property 267 Wakeman Lane will have a temporary construction easement and a permanent slope easement along the river near the bridge. West of that, at 1 Gristmill Lane, there will be a temporary construction easement. Finally, at 148 Old Road number 2, we will have a small permanent take, as shown in blue, and a right to grade, reconstruct driveway apron, reconstruct stone wall, and reset fence along the driveway. From here, Dennis McDonald will explain the rights-of-way process. Dennis?
Good evening, everyone. My name is Dennis McDonald, and I'm a representative from the Connecticut Department of Transportation, Division of Rights-of-Way. I'm just going to provide a brief overview of the right-of-way process. So the function of the Division of Rights-of-Way is to acquire all property and property rights necessary for the project. This is done in accordance with Connecticut General Statute Section 13A73, 13A98E, and the Uniform Relocation Assistance and Real Property Acquisition Policies Act of 1970 as amended. Your typical right-of-way impacts include partial acquisitions, easements, and rights. Impacts are subject to change as the design progresses, but this gives a general idea of typical property impacts. Once property impacts have been established, each impacted property owner will receive a letter of intent to acquire along with a property acquisition map. The letter essentially initiates the right-of-way process, and the map provides a detailed overview of the specific right-of-way impacts. Soon after the letter is received, evaluation process will take place, and once a value has been established, each impacted property owner will receive a written offer of compensation. Property owners will be given time to consider the offer and negotiate should they wish. If an agreement is reached, an acceptance document will be signed, and a closing will take place at a later date. If an agreement is not reached for whatever reason, the state will utilize its power of eminent domain and acquire the property rights through the condemnation process. Now, I understand this has a negative connotation, but many times this is done to keep a project on schedule. If the state elects to pursue eminent domain, the original offer is deposited in the court system, and property owners can continue negotiations or file a formal appeal for a reassessment of damages through the court system. Please note all appeals must be filed within 6 months from the date in which the state files for eminent domain. And that is all I have for tonight. Thank you for your time.
Thanks, Dennis, for walking us through that. So to wrap things up here, construction is scheduled to start in spring of 2023. However, this is subject to permit approvals. The duration of construction will be approximately 8 months. The total construction cost comes to $2,570,000. 80% of this cost will be covered with federal funds, and the remaining cost will be split between Westport and Fairfield at 10% each. Please note that the cost and schedule I've described here are preliminary and have potential to change as the design progresses. This wraps up my portion of the presentation, and I will turn it back to Pretty. Thank you.
Thank you, Rob, and that, ladies and gentlemen, concludes our technical portion of the presentation. I would like to thank everyone on my design team and everyone behind the scenes who helped put this live event together. We are going to leave the Q&A session information on the screen for your benefit, and we will be answering any questions that came in during the presentation and answer any questions that will come in during this live Q&A session. Once again, we would like to remind everyone to please visit the project website to participate in the survey pertaining to tonight's event, or ask additional questions, or view project plans and information. For those of you listening on the phone, the project webpage is again portal.ct.gov/DOT Westport 158-218. So with that, we are now going to start the live question and answer session. We will take as many questions as we can. Feel free to use that chat feature or call in by telephone. The number is again 860-944-1111, or by email. The address is again dot-flbp@ct.gov. And once again, the comment period will be open until October 4th. Okay, ladies and gentlemen, it looks like we do have a few questions that came in. I will read the first question out loud. And the question is, where will the contractor place his equipment? And can I have Rob or Anand from CEHA take that question? Please unmute yourself first. Go ahead, Rob.
Yes, this is Rob with CHA. I can answer that question. The majority of the contractor's equipment and operations will take place within the roadway. All driveways and access to Gristmill Lane, as shown in the plan view here, will remain open at all times, so everyone will still have access to their driveways. But the contractor will utilize the roadway near the bridge and then some area along the roadway to stage the construction.
Very good. Thank you, Rob. We have another question. How long will construction take, and can it be expedited? Can I have Rob from CHA please take that question?
Yep, I can take this one too again, Pretty. So construction is scheduled to take about 8 months. When we looked into the various options for how to make construction operations work for this bridge, we looked at staging and closing the road and different types of bridges. And what we came down to is if we use a bridge closure and a detour, and the bridge type we used has prefabricated elements, it actually ends up being one of the quickest options for construction. So we kept that as one of our goals, to reduce the duration of the detour, and the option that we came up with is ideal for that.
This is Anand from CHA, and the other thing I would like to add is that we are using what, as Rob described previously in his presentation, a three-sided prefabricated structure. Now, this is basically, since it's prefabricated, it's prefabricated in the shop, so when it comes to the field, it can be installed very quickly. It's already cured, so the contractor is not wasting time in any time associated with curing, etc. So the type of structure that we've selected for this bridge also facilitates a quicker construction.
Very good. Thank you, Rob and Anand, for that answer. We have another question. How will the fire, EMS, mail, and bus routes be impacted by this project? So can we first have CHA take that question and then have also the town answer as well?
This is Anand from CHA. So yes, we because the roadway at the bridge is going to be closed, there will be some impacts to the emergency vehicles. But as Rob mentioned in his presentation, the detour route is sort of fairly short. So we believe that with prior coordination and meeting with the emergency services, this can be handled.
Would the town like to add anything else to that answer, or is that sufficient?
Sure. This is Keith Wilberg, Town of Westport Engineering Department. I actually reached out to Al Demira of our police department and Nathaniel Gibbons, our fire marshal, and they said basically from their point of view, they would still use the same routes. It's only if they were trying to do some kind of crossover, a mutual aid call with Fairfield, it would really distract them. So from an emergency response standpoint, the detour is not going to create a big delay. It'll probably create more of a delay for the residents there that are used to obviously traveling in the ways they normally travel.
This is Bill Hurley from the Town of Fairfield Engineering Department, and pretty much the same response.
Okay, very good. Thank you. We do have another question. What color will the bridge rail be? Does CHA want to first take the question, and then we can also have the towns weigh in if they want to?
Sure. This is Anand from CHA. So as Rob mentioned in this presentation, what we are proposing to have is an open steel bridge rail that will be metallized, and it can be sort of metallized to any color of the town's choice. So essentially, it will boil down to the town's preference.
I can add one thing to that. We can also take suggestions from the public, and if you have input on that, you can contact your representative from your respective town, either Keith Wilberg or Bill Hurley, who are both on this call.
This is Keith again from Westport. So far, I haven't heard a lot of input, but what I have heard is the steel rail that's painted black is the most popular.
Okay, excellent. All right, well, we don't have any more questions right now, so let's give it another few minutes. So please don't hesitate to call in with a question. Again, the phone number is, ladies and gentlemen, 860-944-1111. Again, you can email us. The email address is dot-flbp@ct.gov, or you can use that chat function on Teams that we talked about a little earlier. So I'm just going to give it about a minute or so and see if anyone else wants to ask anything else. And while we are waiting for questions, again, I would like to remind everyone that this whole presentation, including the Q&A, it will be recorded and it will be posted to YouTube following this event. The recording will also be made available on the link that's shown on the project webpage. And that link again is portal.ct.gov/DOT Westport 158-218. Don't think we are going to be getting any more questions. We've been on for a little while now. So I think I'm going to take this opportunity to start wrapping up. I would like to encourage you to take the survey link that is shown on the Teams chat box, or for those of you watching on YouTube, the survey is below the video. This would really help us improve these virtual meeting experiences in the future. And please also remember that the comment period is open until October 4th, Once again, ladies and gentlemen, on behalf of the department and the towns of Westport and Fairfield, we would like to thank you for joining us tonight, and we hope that you found this meeting informative and we were able to answer all of your questions. All of us on the design team and both of the towns are always available to answer any questions, even outside of the comment period. We are also available to meet with you individually on the project site if you so desire. Thank you once again and have a wonderful evening.